Okay, this is the video for the practice test. First one says simplify the trig expression written in terms of a single trigonometric function. This one here, I see sine cubed here, and I see sine x, so I'm going to factor out a GCF of sine of x. And that's going to leave me sine squared x plus cosine squared x. And remember that is then 1. So we got sine of x times 1. So sine of x is my answer here. The next one, same approach. Okay, I guess same instructions. I'll approach this one as if maybe I don't see any substitutions. Remember, if we don't have any substitutions, we're just going to rewrite it in terms of sine and cosine. So I have 1 cosine of x minus cosine of x over sine of x cosine of x. I'll make common denominator here. This will be cosine x. So this will give me 1 over cosine x minus cosine squared x over cosine x all over sine x cosine x. This becomes 1 minus cosine squared x up top, cosine x on the bottom, over sine x cosine x. That top there from sine squared x plus cosine squared x equals 1. We can rewrite that top as sine squared x. And now fraction divided by fraction, so multiplied by reciprocal. Cancel, 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 cancel. Leaves me just sine x on top. The next one, evaluate the expression under the given conditions. Okay. So remember, we're going to find this. So it's sine of theta plus phi. Remember, sine of theta plus phi is equal to sine cosine sine cosine sine. And then remember, it just goes theta phi theta phi. Okay. Now we know right away that sine of theta is 20/29. So that thing right there changes to 20/29. Okay. I know cosine of phi is negative 3/5. So that turns into negative 3/5. However, I don't know either of these. So we need to draw a picture. So I'm going to let this one be theta. This picture be phi. So theta, quadrant 2, is 20/29. Okay, and that's sine. So this is 20, and that's 29. Okay, we use the Pythagorean theorem to come up with what the x distance is. So we'll say 29 squared minus 20 squared is 441. Square root of that, 21. So this distance here would be negative 21. Okay. Now I'm going to come over here and do the same thing for phi. We're in quadrant 3. Cosine is negative 3/5. So that's negative 4. Now we can find these. So cosine of theta, that would be negative 21 29ths, adjacent over hypotenuse. And sine of phi would be opposite of our hypotenuse, negative 4/5. So then we get negative 60 over, what's that? So 30 times 5 would be 150, so this is going to be 145. Minus then, or sorry, plus, because negative times negative, 84.
Last question on the auto insurers. Because we're all in these stay-at-home orders across the country right now.
So we 24 145ths.
Are refunding millions.
Remember, we can check this. So I'll go ahead and show you before you turn your assignment in or your test in. You can double check to make sure this question is correct. All right, so I'm gonna go arc sine of 20/29. Do this in degrees, it'll be easier to recognize. Gives me that. Okay, but I'm in the second quadrant, so I actually want 180 minus that. Okay, so that's the angle of, that's how big theta is. Okay, phi, I'm going to find by taking cosine inverse of negative 3/5. Okay, now it says we're in quadrant 3. Okay, so in quadrant 3, I actually want this to be, let's go 180 minus that, and we'll add 180 to it. So that's the angle in the third quadrant. Okay, so I'll call that phi. So I'm just going to check real quick. 20/29 is 0.689. So let's see if sine of t gives me the same number. It does. So we're good there. Obviously, negative 3/5 is negative 0.6. So let's see if cosine of p gives me negative 0.6. So I know that these two angles now are correct. So let's see then if we go sine of theta plus phi, it gives me that right there. Is that the same thing as 24 over 145? And it is. So I know I'm correct. All right, so next one says it's really the same type of problem. Find sine of 2x, cosine of 2x, and tan 2x given the following information. Remember, sine of 2x is 2 sine x cosine x. Okay, so I need to use this 5/13. So sine is 5/13. So 5/13. So that's what, 169 minus 25, 144. So it'd be 12. And remember now, that angle there, that's x. So now I need to go through and just substitute. So I'm going to go 2. Sine of x is 5/13. And cosine x is 12/13. So then we're going to get 120 13ths. And again, you can check that. We can go arc sine of 5/13. That's the angle we're looking for. It's in the first quadrant, so we're good there. So let's call that t. Okay. So then the question is, well, what is sine of 2t? We get that number right there. Is that the same as 120 over 13. Okay, so multiply this out, and hopefully maybe you see the mistake I made. Multiplying fractions here. I don't know why I put it over 13. I think I made that mistake earlier in something else on one of the videos as well. So that's 120 over 169. So now we check that. And now you see that 0.71. So what I also typed in here is what 2 sine t cosine t look like. You see that all three of these are equivalent. So we're good. Now the next one, cosine 2x. It doesn't matter which of the three formulas you use for this. If you remember, what is it? Cosine squared x minus sine squared x is 1. I think 2 cosine squared x minus 1, and 1 minus 2 sine squared x is another one. But since you've already done the work, you've got all this in your picture, so it doesn't matter which one you choose. If you want to use, let's say we want to use this one here. So I got 2 cosine is 12/13 squared and minus 1. So I get what, 144 over 169. Multiply that by 2. Subtract 1. I'll let you finish that math. Shouldn't be too difficult. Or we could do this one where we go 1 minus 2. Now sine would be 5/13 squared. So we get 1 minus 2 times 25 over 169. Okay. So let's just grab our calculator. Again, you're going to further simplify those. Let's just prove that they are the same. If we go 2 times 144 over 169, subtract 1, you get that number. If we go 1 minus 2 times 25 over 169, same number. And then if I did the cosine, so the cosine would have been 12/13 squared. Squared. Then minus the sine squared, which would have been the 5/13 squared. So you get the same thing. Now you would evaluate these, okay? So my hope is that you're getting the 119 over 169 number. But that's what we're looking for there. So now you can use the double angle formulas for tangent if you want to. I'm not going to because I know tangent of 2x is equal to the sine of 2x divided by cosine 2x. So I'm going to rewrite this as, so remember the sine of 2x we found to be 120 over 169. And the cosine was I think it was 119 over 169. So then we're looking at 120 over 119 as our solution there when they simplify. Next one, simplify the following expression. So this is just looking and seeing which formula this looks like. Okay, so this is of this formula here. And matching that up, that is a double angle formula, so that's the sine of 2x. That there is then your x. So what we're looking for here is for you to rewrite this as sine of 2 times 3 pi over 8. Well, that's going to cancel, leaves me sine of 3 pi over 4, and now that should be something we can evaluate. The sine of 3 pi over 4, radical 2 over 2. This one here, this is the sine of an A, cosine of AB, plus cosine of the A, sine of the B. If you remember that, that is the sine, and in this case, sum formula. So we're going to go sine of A plus B, where A is 23, B is 7. So this is going to be the sine of 30, which we know sine of 30 is 1/2. This one here is the cosine. So it's cosine A, cosine B, plus sine A, sine B. So then, if you remember, that is in this case, because it's a plus, this is going to be the difference formula for cosine. So it's cosine A minus B. So it'd be cosine of 110 minus 20, which is the cosine of 90, which we know is 0. These are just looking for so I guess the directions were kind of vague here, but these are just wanting the sine of 3 pi over 4, the sine of 30, and cosine of 90. And then down here, it wanted the radical 2 over 2, the 1/2, and the 0 that goes for A, B, and C. Number 7 says find sine of x over 2, cosine of x over 2, and tangent of x over 2, given the following information, using your half angle formulas. So your formulas for half angle, just write them here real quick. For sine, it's 1 minus cosine x over 2. For cosine, sorry I keep pausing. My 1-year-old is all over the place right now. Okay, so that's sine of x over 2. Cosine is plus or minus. Now it's 1 plus cosine of x over 2. In this, I'm just going to rewrite this as the sine of x over 2 divided by cosine of x over 2. So let's find these things. Says that your angle between, or your angle x is between 0 and 90. So when we're done, x over 2 then should be between 0 over 2 and 90 over 2. So our answer should be between those things. I'm just going to draw a picture here real quick. Sine is 4/5. So remember, sine is 4. That's 5. That makes this 3. So then we're going to go, I know my angle should be between 0 and 45 degrees. So I know this is going to be a positive y value, because all your y values between 0 and 45 degrees are positive. Then I'm going to go 1 minus now cosine of x. Well, remember, this is x. Cosine is now 3/5. All over 2. So 1 minus 3/5 is 2/5. All over 2. Okay. So then that's going to turn into root multiplied by the reciprocal. So what, 2/10? Okay. If you want to leave it that way, that's fine. If you want to, it's radical 2 over radical 10. Rationalize. So you get radical 20 over 10. So that's what, 4 and 5. So 2 radical 5 over 10. So radical 5 over 5. That's okay. Okay. Just kind of check this real quick. We can go we can go arc sine of 4/5. Okay, so let's see here. 10 degrees, so 53 degrees. Okay. So then when I go let's call that t, then the sine of t over 2 is going to be that number right there. Let's see if that's the same as square root of 5 divided by 5. It is. Now we're going to do the same thing. For cosine of the first quadrant is going to be positive. And then we just go 1 plus cosine now of x. Well, cosine was the 3/5 all over 2. So now we're looking at, what, 8/5 over 2. Okay, so that's radical 8 over 10. So root 8 over root 10. Rationalize. So we have 10 on the bottom. This is actually, I'm going to write that as 2 radical 2. So that's 2 radical 20. And that becomes, so that's a 2 and a 4. So that's what, 4 radical 5 over 10. So this becomes, those would cancel. Leaves me 2 radical 5 over 5. So again, checking that just real quick. We've already got the stuff on the calculator. So let's just change this to arc. I guess we change this cosine. Okay, and then we're going to check to see if 2 square root of 5 over, what was it, 5? Gives me the same number. Okay, so now, just to find the tangent, I'm going to take that one, which was a sine, so radical 5 over 5, divided by this one, which is cosine. These 5s are going to cancel, and I'm left with radical 5 over 2 radical 5, which those cancel, and it leaves me 1 over 2. So let's just see if that pans out. So all I've got to do is type in here, tangent, and we get 0.5. All right, so here are our trig equations. It wants find all solutions on the given equation. I want to find infinite solutions and answers in terms of radians. All right. So this one, and isolating the sign is not that difficult. We should add 2 to both sides and divide by 4. So I get sine squared x equals 2/4. Then I'll square root both sides, so I get sine of x. Now remember, when we square root, we get plus or minus, okay? And it's going to be, so this is 1/2. So you get plus or minus the square root of 1/2. Well, that's plus or minus radical 2 over 2, okay? So the question then is, when does the sine equal radical 2 over 2? For what values of x? Well, we should know that that's the pi over 4 increments. So pi over 4 and 3 pi over 4, that's when we're equal to positive radical 2 over 2. 5 pi over 4 and 7 pi over 4 is when we're equal to negative radical 2 over 2. So those are your 4 initial answers around the unit circle. Okay. Now the infinite solutions, we're looking for pi over 4 plus then 2 pi k, 3 pi over 4 plus 2 pi k, 5 pi over 4 plus 2 pi k, and 7 pi over 4 plus 2 pi k, where all of these k is an integer. And I want to see that you tell me that k is an integer. That can be kind of a pain in the butt to write all those out once you have these. If they're all the same plus 2 pi k, if you want to do this, I'm okay with that. If you understand that transforms into these 4 things. All right, so the next one, number 9, says do the same thing, but I only want the solutions between 0 and 2 pi. So we're going to add radical 3 to both sides. So we get 2 cosine 3 theta is equal to root 3. And then I'll divide both sides by 2, so we get cosine 3 theta is equal to root 3 over 2. So now we're going to ask ourselves, well, where does 3 theta equal radical 3 over 2? Okay? And it's cosine. So think about our cosine. When is it radical 3 over 2? It's, so we want radians. Cosine is radical 3 over 2 at pi over 6. And then again at 7 pi, not 7 pi 6, 11 pi over 6. Okay, so that's right there. That's when theta, so that would be the pi over 6. And then right there would be 11 pi over 6 if I go around all the way that direction. Okay, so those would be the two angles that give me the cosine to be radical 3 over 2. So now, well, if you remember what we do here, we're going to take pi over 6, and 3 theta is equal to 11 pi over 6. We're going to add to it our 2 pi and 2 pi. Okay, and now we're going to solve for theta. So theta would be, divide everything by 3 here. So pi over 18 plus 2 pi over 3. This one here would be 11 pi over 18 plus 2 pi over 3. Okay, now remember what we do. We let k equal 0, 1, and 2 for both of these. And it's going to give me then my solutions between 0 and 2 pi. So, when k is 0, my first solution is pi over 6. Sorry, not pi over 18. I went back to this one. It's this one. Remember those guys. There's still got to be a k here with these. Sorry. So when k is 0, that goes away, and I just left with pi over 18. That's my first solution. When k is 1, okay, I'm going to add 2 pi over 3 to that. So as a common denominator, 18, and that would be 12. So 12 pi over 18. So this is going to be 13 pi over 18. And then k equals 2. Okay, if you can see the arithmetic sequence here, I'm adding 12 pi over 18. So I'm going to just add 12 to this numerator, be 25 pi over 18. Down here, the first one, 11 pi over 18. I'm going to add the same, 12 pi over 18. So 11 plus 12 is 23. And then 23 plus 12 is 35. And those are your 6 solutions that occur between 0 and 2 pi. Okay, this question is, the practice test that says bonus. I'm not sure if I'll make this a bonus. This might be just a traditional normal question, okay? For the fact that you got 4 hours, you got endless resources to use, I'm going to mitigate, probably eliminate all bonus on this, and just every question will be for regular credit. So when we look at this, okay, this is an inverse function. Okay, so remember what this does. That right there is a ratio of the opposite side divided by hypotenuse. Okay, so what we're seeing here is that the opposite side is x, the hypotenuse is 1. Okay, so we should then be able to use the Pythagorean theorem to find this distance here. Okay, so that distance there, I'll just call it a for now. So a squared plus x squared should equal 1 squared. So a squared should equal 1 minus x squared. So a is going to equal root 1 minus x squared. Okay, so that gives me this angle here of theta. So what I'm going to write here is I'm going to go say sine of 2, but now this thing here is this theta. So I write 2 theta. Well, what's that? That's a sine double angle formula. So that's 2 sine of theta cosine of theta. So now we can go 2 sine of theta is opposite of hypotenuse, so x, and cosine is root 1 minus x squared. So what we get here is 2x times root 1 minus x squared, and now it's an algebraic expression in terms of x and no longer trigonometric. Okay, we can check this. I think Desmos allows for this. If we graph sine of 2 sine inverse of x, we get that little curve there. Do I get the same thing if I graph in terms of x? So that is kind of validation that they are the same thing. Hopefully this helps. Now, this being said, obviously this is a starting point for your preparation. But you will see similar questions. I'm not saying I'm going to, and it's because we have the external resources, we have the extra time. You might see maybe a few more questions than these 10. I might test you over, instead of giving you just 2 trig equations, I might give you 3 of them. I might give you a couple more of these where we're simplifying trig expressions. Hopefully that's of benefit to you.